In previous class, I have explained 3 examples based on convolution theorem, and this is the fourth one. Find L inverse of 1 divided by s minus 1 into s square plus 1 using the convolution theorem. Solution: we know that what is the working procedure, means how to solve these examples using the convolution theorem. F bar of s into g bar of s is 1 divided by s minus 1 into s square plus 1. Then f bar of s is 1 divided by s minus 1 and g bar of s is 1 divided by s square plus 1. Now we have to apply the inverse. L inverse of f bar of s is equal to L inverse of 1 divided by s minus 1 and L inverse of g bar of s is equal to L inverse of 1 divided by s square plus 1. Now L inverse of f bar of s is f of t, or otherwise keep L inverse of f bar of s as it is, which is equal to e raised to t, and g of t is sin t. Note these two expressions. Now we have convolution theorem. According to that, L inverse of f bar of s into g bar of s is equal to integration from u is equal to 0 to t f of u into g of t minus u du. Then L inverse of f bar of s into g bar of s is 1 divided by s minus 1 s square plus 1 is equal to integration from u is equal to 0 to t. This is f of t can be written as u here. Our variable is u, therefore it is e raised to u into sin t changes to t minus u, sin t minus u into du. See, this is of the form integration of e raised to ax into sin bx plus c into dx. This is a minus t minus u. See, this expression is of the form, we don't know any result to find the integration of these two terms which are in products, e raised to u into sin of t minus u. Here we have to use the result integration of e raised to ax into sin bx plus c into dx. We know that integration of these two is e raised to ax divided by a square plus b square into a sin bx plus c minus, I will write next term here, minus b cos bx plus c. This is the formula, this is the result we have to use in this example. Therefore, L inverse of 1 divided by s minus 1 into s square plus 1 is equal to, here e raised to ax, here a value is 1 and x is u, therefore it is e raised to u divided by a square is, here a value is 1 means it is 1 square, plus here bx plus c, here the b value is also 1, therefore it is 1 square into 1 into sin bx plus c is t minus u plus this value is also See here, in our standard result, it is a into sin bx plus c minus b into cos bx plus c. Here b is coefficient of x, so that here also we have to take b as a coefficient of u, because u is a variable for this integral. Therefore here coefficient of u is minus 1. Here minus 1 whole square, it is minus 1 whole square. 1 into sin t of u minus u, minus into minus 1, it will be minus into minus plus cos of t minus u. I will write this expression again in the next page. That is e raised to u divided by 1 square plus minus 1 whole square, and this one is sin t minus u, this is t minus u, plus I will write next term here cos of t minus u, and here limits from 0 to t. For this expression also limits from 0 to t only. Here 1 square plus minus 1 square is 1 by 2. 1 by 2 is constant. Take outside the limit, e raised to u into, this is flower bracket, into sin t minus u plus cos of t minus u, limits from 0 to t. Next is half into, I will take separate terms. I have to multiply this u to both these two terms. We get, this is a flower bracket, e raised to u into sin t minus u, limits from 0 to t. This is plus, I will write second term here, e raised to u cos of t minus u, limits from 0 to t. Next I will apply the limits. 1 by 2 into, first is e raised to t, when it is u will be t, sin 0 we get, therefore it is sin 0 for upper limit minus e raised to 0 into sin t minus 0 is sin t. This is for first term, plus then apply upper limit and lower limit for the second term, e raised to t cos 0 minus upper limit minus lower limit. Here also upper limit minus lower limit is e raised to 0 cos t. Second term is also over. Now simplify this one. Half into sin 0 is 0, and e raised to sin 0 0 means 0 into e raised to t is e raised to t only, and e raised to 0 is 1. Therefore only we have here minus, this is not e, minus sin t. Next this is for plus, e raised to t into cos 0 is, e raised to cos 0 is 1, e raised to t only, and this is minus e raised to 0 is 1 cos t. It will be half into, I will write positive term first, e raised to t minus sin t minus cos t. Therefore L inverse of this one is s minus 1 s square plus 1 is equal to half into e raised to t minus sin t minus cos t is the required L inverse for the given function using the convolution theorem. And the next example, fifth one, find L inverse of s plus 2 divided by s square plus 4s plus 5 whole square using the convolution theorem. F bar of g into g bar of s is this one. Then f bar of s is s plus 2 divided by s square plus 4s plus 5, and g bar of s is 1 divided by s square plus 4s plus 5. Now we have to apply the L inverse. L inverse of s plus 2 divided by s square plus 4s plus 5, and g bar of s is this one. Now we have to express this denominator is in the form of s minus a whole square plus or minus b square. See here, s square plus 4s plus 5 can be written as s square plus 4s plus this 5 can be written as 4 plus 1. Then this 3 terms gives us s plus 2 whole square. This is plus 1. Now we have to use this result. L inverse of f bar of s minus a is equal to e raised to 80 into L inverse of f bar of s. For that we have to express the numerator also is in the form of s minus a. Here in this term already numerator is in the form of s minus a, and here we have a constant, not s term, so that this is keep as it is. Now L inverse of f bar of s can be written as L inverse of s plus 2 divided by s plus 2 whole square plus 1, and L inverse of g bar of s is equal to L inverse of 1 divided by s plus 2 whole square plus 1. On using this result, we get L inverse of g bar f bar of s is equal to e raised to minus 2t, because a value is 2 here, and and a value is minus 2, therefore e raised to minus 2t. L inverse of 1 s divided by s square plus 1, and L inverse of g bar of s is equal to e raised to minus 2t L inverse of 1 divided by s square plus 1. Therefore L inverse of f bar of s is f of t, which is equal to e raised to minus 2t, this is cos t, and g of t is equal to e raised to minus 2t sin t. This is f of t and g of, it is g of t, not this one, e raised to minus 2t cos t, and g of t is equal to e raised to minus 2t into sin t. Next we have to use the convolution theorem. This is the convolution theorem. F of u is e raised to minus 2u cos u into g of t minus u is e raised to minus 2 into t minus u sin t minus u into du. Now e raised to minus 2u cos u into, here I will simplify this e raised to minus 2 into t minus u, e raised to minus 2t into e raised to 2u sin t minus u into du as it is. Here we have bases are same, powers we have to add here. E raised to minus 2u plus 2u e raised to minus 2 into e raised to minus 2t cos u into sin of t minus u into du as it is. E raised to minus 2u plus 2u will be 0, e raised to 0 is 1, and e raised to minus 2t is constant because here we are integrating with respect to u. Therefore take constant outside the integration, e raised to minus 2t outside, then it is u is equal to 0 to t sin t minus u into cos u du. Now we have to use the result cos A into sin B. We know that cos A into sin B is cos or here I am writing sin A cos B, therefore I will write sin A into cos B is equal to sin A plus B plus sin A minus B. This result we have to use here. Next is equal to after using this result we get e raised to minus 2t as it is, limits from the u is equal to 0 to t. Sin A is t minus u plus u plus sin t minus u into du, which is equal to e raised to minus 2t, limits from 0 to t. Minus u plus u get cancelled, remaining is only sin t plus sin t minus, here minus u minus 2u into du. Now we have easily integrate these two terms. This is what L inverse of s plus 2 divided by s square plus 4s plus 5 whole square. Now I will integrate this one. Sorry, I have skipped one thing here. This is 1 by 2 into this one, therefore it is 1 by 2. This is divided by 2. This have 1 by 2 here. Now L inverse of this is equal to e raised to minus 2t divided by 2 is constant. Now I am integrating. Sin t is constant. Here sin t constant means different integration of this one is sin t into u, limits from 0 to t, plus I will write second term here. This is cos t minus 2u, and this one here we have coefficient of u is 2, therefore it is cos of t minus 2u divided by 2, limits from 0 to t. Now I will apply the limits, which is equal to e raised to minus 2t divided by 2 sin t as it is. First one is upper limit minus it is lower limit, plus second term here 1 by 2 is constant, take outside. For the first upper limit, cos of, when we apply t u as t, this is t minus 2u 2t, therefore it is minus t. Then upper limit minus, when it is 0 it is simply cos t, which is equal to e raised to minus 2t divided by 2 into t sin t. Cos of minus theta is cos theta only, plus 1 by 2 into 1 by 2 into cos t minus cos t. Cos t minus cos t is 0. 0 into 1 by 2 is again 0. Therefore, simply it is e raised to minus 2t divided by 2 into sine t into sine t. Therefore, thus L inverse of s plus 2 divided by s square plus 4s plus 5 whole square is equal to e raised to minus 2t into t into sine t divided by 2 is the required L inverse for the given function. These are the some homework examples. I have already solved all possible type of examples in convolution theorem. Same as those, so try these examples and recall all your trigonometric results and differentiation results. Using that knowledge, solve these examples using convolution theorem.